This will be the last example we're going to go through with 4.2. This is example 13. The only difference really on this one, all the steps are the same, only we're going to actually bound the region to the y-axis now. So, if we take a look, it says find the area of the region bounded by the graph f of y equals y squared, and the y-axis for y being between 0 and 1. If you look at the difference in this graph now, okay, notice the shaded region goes above the curve to the y-axis, where everything else we've been doing has been below the curve to the x-axis. So that's really just the different nomenclature that we're doing with this problem. Everything else is the same. But instead now we're going to do everything in terms of y. So instead of seeing a delta x, we are going to see a delta y come into our scenario. Okay, our interval is still 0 to 1. Alright, so let's walk through this real quick. First step, still finding delta y. Delta y is b minus a divided by n, so it's going to be 1 minus 0 over n. That's our delta y. We're going to solve this problem using the limit process, so we have to find ci. Ci is still a plus I delta y. Let's use the right-hand approach just for simplicity. So ci is equal to 0 plus I times delta y, which is 1 over n. So our ci is I over n. Now we're going to substitute into the area limit model, so the limit as n approaches infinity of I equals 1 to n of f of ci times delta y. Now we're going to take that ci that we just calculated, which is I over n, and we're going to substitute it into the original function up here, y squared. Okay, so that's why it becomes I over n squared, and then we still have to multiply by delta y, which is 1 over n. So all the rules here still apply. Let's go ahead and square that n and distribute the 1 over n. So what we get is the limit as n approaches infinity of I equals 1 to n of I squared over n cubed. Now you guys know the drill. We're going to factor out the n cubed, so we're going to have the limit as n approaches infinity of 1 over n cubed times the sum of I equals 1 to n of I squared. Now this is something we've done over and over and over. We have the sum of I squared. We're going to go back to theorem 4.2 on page 2 of the notes here and rewrite its equivalence in terms of n. We've done that a lot. I'm not going to go through the steps, but when we rewrite it, it's n times n plus 1 times 2n plus 1. Remember, you need to FOIL that out, distribute that n through. Okay, we've done that multiple times, so if you still get stuck, I would try it on your own and then look back at the notes and see where we've actually done that to see what your final answer is just for that piece. Alright, lastly, when you work all that out, you've FOILed all this out, distributed this n, distributed the 1 over n cubed, and you've written all your separate fractions like we did in all the previous examples, you're going to get the limit as n approaches infinity of 1/3 plus 1 over 2 to the n plus 1 over 6n squared. Just reviewing, limit as n approaches infinity of 1 over any sort of infinity goes to 0. So the 1 over 2n goes to 0, the 1 over 6n squared goes to 0. So really we're just left with 1/3. So going back and looking up at our given solution or picture here, okay, when we are going from 0 to 1 in the y direction here and bounded to the y-axis, this shaded region is 1/3. Okay, so here's what I really want you to think about. If this is a 1 by 1 box, okay, and it looks closer to, a little bit more than a half, but if we have this curve here, if this was a 1 by 1 box, the area would be 1. But we're only doing the shaded region, which is from the curve to the y-axis. It ends up being about 1/3. Okay, I don't graphically have that drawn accurately, but it's just more of just for you guys to kind of see what's going on there. Now, one that can really help you guys grow, I would like you to work example 14. I have the steps. You guys know all the steps. Find delta x, find the ci, substitute in. I have done this one in detail. It's one that you should do kind of on your own for practice. Real similar to one of your homework problems, so it'll really help you. Alright, I'm not going to work through it, but it's y equals x cubed minus x squared. You're going to the x-axis on this one, and you're going to go from -1 to 1. So a is 1, b is or I'm sorry, A is -1, B is +1. Okay, so when you got to calculate your delta x. I've done all that for you. I've gone through all here step by step. If you need reviewing on distributing the n through the n+1 here, or foiling this out and distributing n, or doing those sort of things, everything's kind of step by step here. So work through this one on your own. See if you actually end up at the same answer that I have down here as 2/3. If you don't, go ahead, shoot me an email. But this is it for 4.2, and we will be on to 4.3.